Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 17C, Circles, Miscellaneous. Math exercise 17C, cancel the following questions: 1, 2, 3, 5, 6, 7, 10, 11, 14, 17, 21, 22, and 25. Let's start with question 4. In this figure, chord ED is parallel to diameter AC. Okay, let me put the parallel sign here. Angle CBE is 65. We have to calculate angle DEC, that is this angle. We have to calculate this one. Is there any other angle cutting the same arc? No. But this is definitely equal to this one. They are alternate angles. It's forming a Z and they are parallel. If they mention parallel, then definitely it will be of use while solving the sum. If only I can find this angle. Now here in triangle AED, I know this is 90. So this is 65 because this angle is equal to this angle. So done. So first you'll see this is 90 degrees because it's angle in a semicircle. Then this angle is 65 degrees because angles in the same segment. They are cutting the same arc EC. Can you see that? In triangle AEC, I got 65 and 90. Angle sum property, I can find this, which comes out to be 25. And then it forms a Z, so alternate angle. So this is also 25. Here are the steps. Now the 8th question. Here it's mentioned AF is parallel to CB, and this is given as 20 and this is given as 92, and we have to find angle BCD, that is this angle we have to find. Okay, how do we find this? If only I can find this, then I know that supplementary angles, these are supplementary angles because it's a cyclic quadrilateral. This is 92, so this has to be 180 minus 92, so that will be 88. So this is 88 for sure. Also, if this is 88, then this is also 88 because they are alternate angles, and it is given that AF is parallel to CB. Now if this is 88 and this is 20, then the total angle, that is angle EAB, is 88 plus 20, that is 108, and that is actually an exterior angle for the cyclic quadrilateral. If you extend the side DA, then BAE is entirely an exterior angle for a cyclic quadrilateral, and we have a theorem which says that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So adjacent to this we have this angle and opposite to that we have this angle. So this angle will be equal to this angle. So if this is 108, this is also 108, and the sum is over. These are the steps. Make sure you write the steps exactly the way I have. While writing each step, you keep looking at the diagram, draw the diagram. It's compulsory for each sum. Keep looking at the diagram to understand what is happening, understand the logic behind each step, write the reasons as well. Don't just copy. 13th sum. Again, the diagram is not given, so we'll have to draw the diagram. And drawing this diagram is very challenging. Let's see if you are able to draw this one. Yep. PQRS is a cyclic quadrilateral. SR and PQ are extended, they meet at point B. RQ and SP are extended and they meet at point A. And this angle PQR is given as 135 degrees. Also, it is mentioned that angle A ratio angle B is 2:1. So I can assume this to be 2x and this has x. we have to find the value of x and find the angles A and B. So in this sum, first of all, if this is 135, it's a cyclic quadrilateral, so if this is 135, this will be 45. Now in triangle SRA, in this triangle, this is 45 and this is x. So by angle sum property, how much will this be? 180 minus 45 minus 2x, it will be 135 minus 2x. This is angle R. Similarly, in triangle SPB, if this is 45 and this is x, then how much will this be by angle sum property? It will be 135 minus x. Now, angle P and angle R are opposite angles of a cyclic quadrilateral. That means this plus this is 180. So, on solving this, we can get the value of x and then we can substitute and get the value of angle B and angle A as well. Here are the steps. Try to write all the steps on your own. Now that I have explained the sum, you can draw the diagram and try to write the steps on your own and see if you are getting your steps correctly, because writing steps is very important. That's how you'll get full marks. You may be able to solve the sum orally like I did, but in exams you should be able to write statements. It's such a long sum, although I explained it in a few seconds. Next, read question 16. So here PQ is given as 7 centimeters, QR is 6 centimeters, RS, it says 3 times of RS is 6 centimeters, means RS is 6 upon 3, 2 centimeters. And we have to find the perimeter. That means this plus this plus this plus this, PS. But PS is not given, so we have to find PS basically. How do we find that? Well, first of all, in triangle PQR, this is 90 degrees because it's angle in a semicircle. It's given PR is a diameter. We're not assuming that, it's given. Even angle PSR is 90 degrees. It's an angle in a semicircle. So we can use Pythagoras theorem in these two triangles. If I use Pythagoras theorem in triangle PQR, I will get the value of PR. That will be useful because that value of PR I can now use in the next triangle, triangle PSR. So I have the value of PR and SR. I can find the value of PS using Pythagoras theorem. Then when I add all 4 sides, I get the perimeter. So write all the steps now. Now the 18th question, the diagram is not given. In a cyclic quadrilateral, AD is equal to BC. So 2 chords are equal. Some angles are given and some angles have to be found out. So this is the diagram. Let's see if you can draw the diagram on your own first. Go on, try on your own. You should be able to draw the diagram. If you can't, then in exam, how will you solve? Does your diagram look like this? 2 chords are equal. First of all, even without reading the question ahead, what information can I get from this diagram? I know that if this is 70, then this will also be 70 because angles in the same segment, they're cutting the same arc. What else? This angle, if this is 30, then this will be 30. Again, angles in the same segment, cutting the same arc BC. You should be able to visualize now. In triangle BDC, if 70 and 30 are given, then I can find angle sum property. So this will be totally 80 degrees. What else? If angle BDC is given as 30, then definitely angle ACD is also 30. So this is 30. Why? Because equal chords subtend equal angles. BC chord is subtending angle BDC and AD chord is subtending angle ACD. So if the chords are equal, the angles at the circumference will also be equal. That's a property. So if this is 30, that means this is also 30. That means this part is 50 angle BCA. If this is 50, then angle BDA is also 50 because it's angle in the same segment. So you can see that we can find so many things. Another thing I observe is that this is totally 80 and this is totally 100. So that's the cyclic quadrilateral property satisfied. So there are multiple ways to solve the same sum. I can go on, but let's start with the sum now. Roman number 1, angle BCD is asked. BCD. I got it, 80. Roman number 2, BCA. BCA. I got it, 50. ABC. ABC. Now this angle is asked. Well, here there are few methods now. First of all, I know this is 50 and 30, so this will be 100. So this will be opposite angle will also be 80. 100. This is 80, so this will be 100. Opposite angles of a cyclic quadrilateral. If this is 100 out of this, this is 70, then this will be 30. Another method you can do is angle ABD is equal to angle ACD. Angles in the same segment, and ACD I just proved it to be 30. So this is also 30. Next, they want angle ADC. ADC. I got it, 80. Now the steps. Now the steps may be different from what I've just spoken because, as I said, there are different methods. So please try to solve on your own. Don't just copy, or after every step, look at the diagram and understand what is being done. Rewind and watch it again if you want. 23rd sum, the last sum. So again, 2 equal chords are there. That's great. And 30, 70 are given. First, angle BCD is asked. This whole angle is asked. BCD. How do I find that now? First of all, I can see that this is 70 because DAC and DBC are equal angles in the same segment. Now this is totally 100, so this has to be 80 totally because they are opposite angles of a cyclic quadrilateral. Next, angle BCA. BCA, that is only this part is asked. So now there are many ways to go about it. I'm going to say that angle ABD is equal to angle CAB is equal to 30. How? Well, equal chords subtend equal angles. AD is subtending angle ABD and BC chord is subtending angle BAC. So they will be equal. So this is also 30. Now if this is 30, but I still have to find this one. Alright, how about this? Angle DBA is equal to angle DCA, angles in the same segment. So this part is 30 and totally it was 80. So 80 minus 30 is 50. So this part is 50. Another way you can do is in triangle ABC, angle sum property. So this is 30 plus 100. So remaining is 50. Another way you can do it is in cyclic quadrilateral. The entire angle is 100. No, that won't work. But you have to keep trying different methods. Next, angle ABC, that's totally 100. Angle ADB, well, that will be equal to angle ACB, angles in the same segment. So if this is 50, this is also 50. Or you could have done angle sum property in triangle ABD as well. So now write the steps on your own and see. Check with these steps. You may have done it a different method, that's okay. But make sure you write reasons for everything you solve and write Roman numbers.
Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.